In this lesson, we want to be able to say that I can graph and apply linear inequalities. Before we actually go through it, we want to make sure we understand what these words mean. Inequalities, you guys have seen inequalities before. We've talked about them a little bit. Inequalities is basically a way of us to be able to compare two objects. Is it bigger than? Is it less than? Is it bigger than or equal to it? Is it less than or equal to it? Typically, we see them as these symbols. We have the less than symbol. We have the less than or equal to symbol. We have the greater than symbol or the greater than or equal to symbol. It's a way of comparing two objects. A linear inequality is just like an equation, a linear equation, except for instead of the equals to sign, they put an inequality instead in place of that equals to sign, so that we are comparing the two sides. We are seeing, is one side bigger than? Is it less than? Is it bigger than or equal to? Or is it smaller than or equal to? So an example of that could look like, we could have y is bigger than 2x plus 7. That's a linear inequality because instead of an equation, instead of the equal to sign, we have an inequality in place of. Boundary. A boundary is a line, especially for a linear equation, it's a line that separates the solutions from the non-solutions. Okay, so we're going to say a line that separates the solutions from the non-solutions. Here's a picture of that. If we have a graph, let's say that this is going to be our inequality. This will be our line that we have, our linear inequality. And we could look at it as this side of the graph being the solutions. Whenever it's inequalities, we are going to end up shading in either one side or the other side. The boundary is this edge. It's the white piece of the graph. It is a piece saying you cannot pass any farther. We have to stop right here. And depending on which inequality you have will depend on what your graph looks like. If you have a, let's go back up here, strictly less than sign in your linear inequality, this will end up to be a dashed line. So strictly less than, dashed line. Strictly greater than, dashed line. If it is less than or equal, we have a solid line. And if it's greater than or equal, we have a solid line. Okay, main difference is that without the equal to sign, it cannot equal the boundary. The boundary is not part of the solution. If it has the equal to sign underneath, then the boundary is part of the solution. Let's look at what it means to be a constraint. A constraint is a restriction that limits possible solutions. So one way we could look at this is we could look at real life applications in the sense of if we wanted to buy a certain number of objects, if we wanted to buy a certain number of books, we are limited to only the positive numbers. We cannot have any negative numbers. That would be a constraint. We are constrained to only have positive values if we were trying to buy objects. We cannot buy negative values. So that would be an example of constraint. Let's look at some examples because we want to be able to say that I can graph linear inequalities. So here's how we graph it. We graph it just like we graph an equation. So first thing that we're going to do is we are going to find the boundary. That's step one, find the boundary. So let's just rewrite this as an equation, as the equal to. Well, in order to graph this, we need 2 points. We need to know what the 2 points are. One way we could graph it is we could write it in a different format. We could write it in our slope-intersect form. That could work. Another way is we can just choose 2 points. So let's actually do it the choosing points method. Let's make a table, and we are going to have x values and y values. let's choose for this one, let's say that x was 0. If x were 0, then this means that we have 0 plus 3y equals to 6. Okay, so in other words, 3y equals to 6. Solve for y, divide by 3, so y is equal to 2. So we have a point at 0, comma 2. Let's pick another point. It does not matter which point you choose. You can choose positive values. You can choose negative values. It does not matter. Let's choose, for the sake of it, let's choose 3. If you choose 3, this would be 3 plus 3y equals to 6. Subtract by 3 on both sides. We end up with 3y equals to 3. Divide by 3, so y is equal to 1. So at point 3, we are at 1. And this is whenever we have to start paying attention to our inequality. So whenever you look at our inequality, what I just said a little bit ago, if it does not have the line underneath, then it's a dashed line. If it does have the line underneath, meaning equals, then it is a solid line. So no line, this means that we are going to have a dashed line going across. Yes, I know that my line is not going to be 100% straight, but if you were to continue this, you will end up with more of a straight line. Let me actually do it this way. I want to go and I'm going to grab this and go make a straight line. And I'm going to do my dashed line over top of that. We're going to make it work. We're going to get there. Okay, so we have the line, and let's make it to be dashed. So we're going to just shade it in. And for you guys, you will have, hopefully you will have a straight edge so that you can actually make a straight dashed line without having to do like what I had to do. So if you take a ruler and just make a dashed line with that, that works best. Now the last part is we need to figure out which side to shade. Because with inequalities, one side is bigger than the other, so we have multiple answers. Remember, since it's dashed line, this line does not actually count as part of the answers to the equation or to the inequality. So let's go ahead and figure out which side we have to shade. Well, in order to figure out which side we have to shade, we are going to choose one random point. Okay? This point has to be either above the line or below the line. It cannot be on the line. So, for example, we can choose, let's say we could choose 0, 0. That would be a good point. It's not on the line. Any point that's not on the line, you can choose. If we chose, let's say 4, 6, we could choose that point. It does not matter which one you choose. So, for the sake of it, I'm just going to choose 0, 0. If we choose 0, 0, this would be 0 plus 3 times 0 is bigger than 6. 0 times 3 is 0. 0 plus 0 is 0. So is 0 bigger than 6? No, it's not. So because that did not work in our inequality, we know automatically that that side of the graph will not have any solutions. So we shade the opposite direction. So we are going to actually shade this direction. Okay, so it's everything over here. So this is where our solution set. So this means that if we chose any point in this yellow shaded region, it would be a solution. Does not matter which point you choose within the yellow solution, within the yellow region. It would always be a solution because the other side would not work, because a boundary says that anything below this is out. Anything above it is in. It's part of the solution set. So that is one example of how to graph. Let's go ahead and look at another example. Same sort of thing. We have our y is greater than or equal to negative 1 over 2x minus by 5. Let's write this as an equation. Now let's graph it. Notice this is in y is equal to mx plus b. We have our slope, we have our y-intercept, so we can just put that on the graph nicely at negative 5. And we can rise by -1 and rise by 2. Or we can rise by 1 and run by -2. So if we go up by 1, run by 2, we can go up by 1, run by 2, go up by 1, run by 2. We can find another random point that's going to be on this graph. And I'm going to do it the same way I did the last one. I'm just going to draw a straight line. Hopefully it will be straight. And then I will fill in what needs to be filled in. So let's look at our inequality. Is it going to be a solid line or a dashed line? The answer is it's going to be solid because we have this fancy little line underneath. That means it can be equal. This means that the boundary is part of the solution. The boundary would not be excluded from our solution set. So if we chose a point on that line, it would satisfy the inequality. Now let's practice shading. Let's choose a random point. For the sake of it, I'm going to choose a different number than the 0, 0. 0, 0 is usually a really good point to choose if your graph does not go through it. But we're going to choose a random point that's not on this line. So let's go with 2, 2. Does not matter which point you choose. So we have 2 is greater than or equal to -1/2 times 2 minus 5. So 2 is bigger than or equal to -1 minus 5. So 2 is bigger than or equal to -6. And that is true. That point satisfies that inequality. So that means that that side of our graph is our solution. So let's go ahead and shade in that region. So we're going to shade it in with the yellow. So this is the solution to this inequality. We're just going to shade it in real quick. Any point you choose within the yellow shaded region would be a solution. Also, the line itself, the boundary, would be a solution in this one because it's not a dashed line. It's a solid line because of the equals. Let's look at this example right here. We're told that a school's music club offers 1-hour piano lessons and 30-minute guitar lessons. The music teacher has a total of 8 hours per week to give lessons. Part A wants us to write an inequality to represent the number of piano lessons and guitar lessons that he can be offered each week, then graph this. So we are going to first make ourselves an inequality. We're going to specify what our variables are and what they mean. So we have 1-hour piano lessons. That's one thing we need to know. We also need to know that he gives 30-minute guitar lessons. And we also know the last thing, that he has a total of 8 hours every week that he can do this. So we're going to look at this in terms of each week and also in terms of hours. So 1 hour, of course, is 1 hour. And let's use the variable P to represent the piano lessons, how many piano lessons he can have. And let's use G for guitar lessons, how many guitar lessons he can have. So we would have 1P for piano lesson. How many piano lessons can we have? Times that by 1. Then we are going to add the times together with the 30-minute guitar lessons. However, the guitar lessons are in 30 minutes. So in other words, that's a half hour. So this would be a 1/2 of the guitar. And we are needing it to be no more than the 8 hours. So this can be less than or equal to the 8-hour time slot that he has. So that's our inequality that we have. We have our piano, we have the guitar, and that has to be less than or equal to the 8. So let's figure out how we are going to graph this. Let's say that our piano, let's make the X the P for the piano lesson. And let's make the Y value to be our G for the guitar lesson. Okay, we're going to have the X be the piano. We're going to have the Y be the guitar. So let's go ahead and graph this. We're going to graph it just like we would graph an equation. So we're going to have P plus 1/2G equals 8. Let's choose 2 points. Let's make a table. So if we make a table, we have x, we have y. Let's choose 0 for the first one. Then let's choose, actually, I want to choose it for our, let me make sure I put the right variables. We have p, we have g. I'm going to choose in terms of g this time. I'm going to choose 0 for g, and then I'm going to choose, let's say, 2 for g, and see what happens. So if we choose 0 for g, we have p plus half of 0 equals 8. So in other words, p is equal to 8. If we chose 2 for the g, p would be 1 over 2. P plus 1 over 2 times 2 equals 8. So in other words, p plus 1 equals 8. In other words, p is equal to 7 because we minus by 1 on both sides. Putting this on our graph, putting this on the graph. We have 8, 0, which would be right here. We have 7, 2, which would be right there. And let's go ahead and make ourselves our line. It is going to be a solid line because it has an equal to underneath. And then from here, what we're going to end up having to do, let's go ahead and look at this. From here, we need to figure out where we're going to graph. Notice, we are going to have some constraints with this. We cannot teach a negative amount of lessons. So a constraint that we could have with this is we are only going to limit ourselves to positive values. We cannot teach a negative amount of guitar lessons either. So we are only going to look at the positive values. Yes, our graph has more numbers, but whenever we're actually looking at a real life scenario, we would always remember that we had to have the constraint of only positive values. All right, let's go ahead and highlight our answer. Let's go ahead and just choose a random point. Best point to choose is 0, 0, so I'm going to choose that. That's over here. He could choose to teach 0 piano lessons and 0 guitar lessons. Maybe he had no students that week, or maybe they were on spring break. So if we choose 0, 0, this would be 0 plus 1 over 2, 1 over 2 times 0 is less than or equal to 8. Well, half of 0 is 0, 0 plus 0 is 0, and 0 is indeed less than or equal to 8. So whenever we're doing something like this, we are going to graph. Our solution set would technically be all of this with our regular stuff that we're doing. However, keep in mind the constraint that it would actually only be the positive values in a real life situation of this. So if a teacher actually had this, we would technically only have to graph the positive values. We would not have to have the extra negative values in our solution set. Last part, part B. Can the teacher schedule 4 piano lessons and 10 guitar lessons? 4 piano lessons and 10 guitar lessons. Well, we have the solution set. So now let's just figure out where this is on the graph. 4 is the P, the x-axis. 10 is the G, the y-axis. So let's actually just put that on the graph. So 4, 10. That would be right here. That's on the opposite side of the shaded region, so no, he would not be able to. Also, we could plug it in. So this one, he would not be able to teach 4 piano lessons and 10 guitar lessons because he'd be having to work too many hours for his allotted time. Let's also plug it in. So this would be 4 plus 1 over 2 times 10. And then we're going to compare that to the 8. So this would be 4 plus half of 10 is 5, less than or equal to 8. So we have 9 is less than or equal to 8. We can see that that is not true. So we would be able to explain that he would not be able to teach this amount of piano lessons and guitar lessons because he would be over the amount of time that he has allotted for giving lessons.